All right. Thank you all for coming out tonight for Fun and Games with Perl. There will be two presenters tonight who basically took the same problem and approached it in different ways. And so it'll be kind of a comparative study. I went minimalist, so I'm probably going to take up a lot less of the time and zoom through it. There's actually not too much to the code. So to give a little background as to why the heck I did this in the first place, really there's no justification, but I downloaded Words with Friends and then I realized I have no friends. So it had a computer mode, you could play the computer, but the computer like destroyed me every single time because guess what? The computer has access to the dictionary. I don't. So I'm like, wait a minute, this is not fair. And I'm like, I'll show you, computer. And I found the dictionary and, started whipping up my own script. And thereafter, I never lost a game against the computer. I destroyed it. So then it turned out I actually did have a friend who was playing the game, which I wasn't aware of, and he'll be up next presenting. So we're literally going to go by the seat of our pants here. This is a view of my phone, a view of the game for those of you who have not seen it before. It's kind of Scrabble-like. Basically, I've got my letters down here. I've been saving this game for like a month now just because the first time out, I got a blank tile. And I was like, okay, I want to demo that. So I'm like, I'm not going to play this game. I'll just leave it there. So basically, that's a wild card, but you don't get any points for it. So what I'm first going to do is go ahead and run the program, go through a few turns so you can see how I use it in practice, and then we'll go through the code. So just like on a cooking show, luckily I typed this in earlier so I don't have to do it now. Basically, this part right here, these are the letters. The dot indicates the wild card, just because regular expressions, why not? So, and then I'm just piping it to more because as soon as you get a wild card, you get a ton of, potential words back. So just piping it to more because I'm sorting by score, highest score first, so I don't care about any of the bottom ones. So I'm going to go ahead and run it. These are the regular expressions. They went by too fast, but actually, hang on. There we go. Just so you can see what the program's actually doing. Those are the regular expressions I'm generating. And then they all go down into this regular expression is the one that's actually executed, which is basically just looking at all the possible, ways that those letters can match words out of the dictionary. And I'll get into the details of that. With mine, again, I went minimalistic. So you do have to use a human brain a little bit. Like for instance, even though this is a point higher, I'm not going to use this word because it's shorter, and you've got like bonus spaces that you want to hit, and I don't account for that in my scoring. This is just raw scoring. If you had this word and they were all blank, no bonuses, that's how many points it would be. So I'm going to go with Zebek, because why not? I have no idea what that even means, but hey. Let me double check the spelling. Yeah, it was CK. It's magic. It involved a lot of goat's blood and stuff. No, it was an app I found last night. It's pretty cool, but it took a really long time to get it working. So I'm just hoping it'll last actually through my talk. Oh, thank you, guys. EC. And then I tell it which one that is. Zebek. I get a nice 40 points for that. Yay. So I'm going to go ahead and play that. Yes. Okay. And then I get new letters, as you saw there. And then the computer, oh, yeah, I'm going to get an ad. Yay. Oh, yeah, I forget. It makes you wait for some unknown reason on the computer. I don't know why. So while I'm waiting on the computer, I'll play before I play another one, I'll actually start going through the code. So for people who are not familiar with GDBM, it's just basically a DBM file. You can think of it as an on-disk hash. Basically, that's what it is. It's just a persistent hash that's on disk, so that every time you run the program, it just loads whatever's in disk to or on disk into the hash that you tell it to. So I've got a map here of all the different letter scores. Obviously, that's where I come up with my scoring. So my first thing that I ask for are the letters, and then I also have a filter, which you don't need on the first turn, but you do need a lot later. Positional regular expression that allows me to filter down to, because there are going to be a lot of words that if I don't filter it, a lot of words will be generated that are not possible. They're possible with the letters I've got, but they won't fit on the board. So I can actually write a regular expression that ensures that it can actually fit. So I set up my words. I've got my normalized dictionary. And by normalized, I mean I took every single word in the dictionary, and the key is the sorted letters that are in that word. The value is possibly an array because more than one word may map to the same value, same sorted letters, but usually it's just one. It's an array of one thing. And then here's where the magic happens. I tie words to that GDBM file. And so now anytime I access this hash, if I add to it, it's going to write it to disk. In this case, on this program, I'm just reading from it. So I'm not changing anything. I just read from it. So while I'm going to kind of have to toggle back and forth, and I apologize for that, but it's just kind of annoying. So you can see I'm killing it so far. So I've got a new set of letters here. And let's say I want to play off the Z and go for that double word. You see the double word down here? That would be awesome if I could score that because the Z is worth a lot of points. So now I'm going to show you the filtering and how that works. So TTSAY. Now those are the letters I have in my hand. I add one more letter, which is the Z, because that's a letter I'm playing off of. Then I'm going to say Z dot 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 dot, and then I'll just be kind of arbitrary at this point, and I'll just say I want it to end on the double word. I can make this a lot more flexible, so I'll probably show different variations. I'll pipe it to more just in case, but I have a feeling, okay, so I came up with nothing. So that whole plan didn't work very well. So now what I can do, well, what I'm first going to do is see is there anything now at all. I'll take the filter completely off. Oh, whoops, except for Sorry, I can't take it entirely off. I have to at least have a Z. So I'm going to put a Z in there. We'll see if I can get any word. Okay. Why not? That looks pretty good. So, yeah, it's like who came up who came up with these words anyways. But see, I get to use a Y, which is high scoring, so that's pretty cool. S I A. Yeah, I'm presenting. So anyway, I'm looking at that. That's if I can get like a 30-point word or higher, yeah, I'm going to go with that. I mean, I could sit here and exhaustively check a whole bunch of things.
That's not on the screen, by the way.
Oh, sorry. Thank you. So anyways, I'm going to go ahead and say yes. You can probably see that I actually did play that there. Thank you for that. So that was a 34 pointer right there. And yay, another ad. So we'll go back to the code real quick. That'll probably be the last one, but hopefully you get the idea with the regular expression. I can literally, if I've got two parallel words with a space in between them, I can actually enter both letters and a dot in the middle. And, it's as flexible as it can possibly be in my opinion. So that's why I did it minimalistic so that it's very flexible so that I just pick whatever looks like a likely thing that is going to score high for me on the board. And then I run it through and then, run my filter on it. So in the interest of time, since I need to give Marty enough time here, I'm going to go ahead and just go through the rest of the code. Everybody kind of good, though, that they understand how that regular expression filter works? You'll understand probably even better once we go through the code. So, forgot to, there we go, put in line numbers. All right, so here is, I'm getting a count of the wildcards. By the way, there's only 2 wildcards in the game. So this is actually a limitation here. You see I've got a to-do. I don't actually have this working if you get 2 wildcards in the same draw, but, odds are pretty far against it, so I haven't implemented that yet. So it just figures out what the count of wildcards is, and then for each position, it just literally goes through and puts the dot in each different position, and that's that list of regular expressions that you saw where I was listing, if I can scroll back far enough, you can see there. You see how the dot just moves diagonally. I'm just trying it in each space, but I'm putting a question mark after every single thing because all of those, I consider all of those optional. Otherwise, I limit the number of words that come back. So, it's anything optional, be optional. But you notice these are all sorted too, right? The letters are sorted. I can enter them in any order I want. And the code actually sorts it for me. And that's what line 50 does. Is I just do a split on the letters and I sort them, and then this is where I add the question mark to make it optional. And then here, back down to here where we were before, this code only gets run if I do have a wild card. And in the first case I did, so you saw where it's putting this dot question mark. It's just iterating through and just figuring out every possible position it can try that in. That's why when you run in the program with a wildcard, it actually takes a lot longer because it literally has to iterate through everything in the dictionary multiple times for each one of those regular expressions. So there's 1, 2, 3, 4, 5, 6, 7. Yeah, so it loops through everything brute force 7 times. All right. Then what I do is down here, this gets run regardless of whether you have wild card or not. And what I do is I push the words in here into the array words, and then for each word, I go through it and I match the regular expression against the key. And the regular expression is actually this whole thing. So the second time I did this, I guess I'm not printing out the regular expression. I'm only doing it here. It's actually much simpler. It's just one little bitty regular expression. So that's why I'm not actually printing that out. And then I call score word on the word, and that just goes through and does like a lookup table. Says how many points is each one of these worth, adds up all the points, and returns the word score. Is that pretty clear to everybody? I know I'm going through this pretty quick, but it's pretty basic stuff. It's not doing anything fancy here. And then I'm printing each one out. So, but this right here, this is the business. Line 91, this is pretty much the most important line in the whole program. That's the part that matches the regular expression against each one of the words to figure out, is this a potential out of these things that I was given? And the way that it works, I sorted everything by letter. Again, you remember, as the key, the value are the potential words that can be made out of those letters. So then, when I enter letters, I create a sorted regular expression, which then matches against that. Because otherwise, if you don't sort them, you end up with all kinds of crazy potential matches, which are not, completely bogus. So basically, I sort both, do the regular expression, and calculate the score, and dump it all out. Any questions? That's pretty much my presentation.
We see low DBM.
Oh, yeah. I was actually going to go to that if there were no questions, so thank you. Yeah, this is pretty much it. All this does, the dictionary was literally just a text file with one word per line, nothing fancy. So I, again, just tie. I do my tie. I'm using IO all, but don't worry about that too much. That's just basically doing my IO stuff, opening files, slurping, and junk like that. So you notice it's the same normalized dictionary, and you see this flag, WR create. What that means is it'll look and see, does this file exist? If it doesn't exist, it will create the DBM file. And in this case, that's what I wanted, because I had no DBM file until I load everything in. If it already exists, it will just add whatever new keys come in. Or in this case, if I reran it against the same file, it would just go and literally replace every key value pair with the same key value pair. Kind of pointless, but that's what would happen. So basically, I'm just going through and looping through each line, chomping it, and then here's where I'm sorting it. I don't know, maybe I shouldn't gloss over this detail, but if you use an empty set of slashes, it basically will split on every character. So that's what that trick is. That's just kind of a little tricky. I've actually used that a lot, but they put that specifically in there so that you can do this sort of thing. It makes it really convenient. So I'm literally just splitting up the words, I'm sorting them, and then I'm joining them on the empty string. So that's all the magic there. And then I'm just turning off warnings because it complains if you've got undefined values. And then I use the sorted word again as the key, and the actual word, oh, sorry, I said an array, but it's actually their new line terminated. It's not actually an array, but anyway. It serves the same function, yes.
I thought a few weeks back you were worried a little bit about the speed, but it looks like it's pretty quick. Did you do anything to speed it up?
Well, Okay, the question was that I was worried about speed. Did I do anything to speed it up? The answer is I actually did try to optimize because I thought I could optimize it, but it turns out that my optimization was crap because it basically broke the program. It was faster, but it didn't give me good results, so I ended up tossing that out. So, any other questions? I want to make sure Marty's got enough time. All right. So, anyways, the rules I set for myself were basically I don't use this against any real person. I only, I guess that makes Marty not a real person. But no, by agreement, we agreed that we were both going to cheat. I wouldn't cheat on an unsuspecting person. So I use it against the computer, and I use it against my good friend Marty because we agreed that we would. So thank you very much. And if there are any more questions you think of later, you can catch me after the talk.